Let's get started with first module. In the first module, we'll talk about the evolution and introduction to Lean Six Sigma. So what is Six Sigma? What is Sigma? Let's first talk about Sigma. Sigma is nothing but standard deviation. Now, it's not a standard deviation to its true sense. What we mean by Sigma is the process capability. How much is your process capable of? If it is Six Sigma, if you process Six Sigma, then we would be having an opportunity of 3.4 defects per million, right? Per million is huge. Per million opportunities, we can have maximum 3.4 defects. That is your Six Sigma process. Now, all that it means is how many standard deviations you can fit into the specifications given by the customer. So the customer gives out a target value. Now, he doesn't always give you just a target value, he also gives you the tolerance limits. Why he gives you a tolerance limit? Because it's a globally accepted factor that no two parts are going to be similar, right? Everything is going to be, every part which is getting manufactured or produced is going to be different from the other part, right? So no two parts are going to be similar. You might or might not be able to make out the difference using your naked eye, but the difference is there. It's just that you require a better gauge to be able to find out the difference. Maybe, you know, much more granular level you would be able to find it out, but the difference is there. Let's take an example over here. So let's say you are a supplier and a car company comes to you. They say that manufacture nut bolt for me. Now, among the various of the specifications of, let's say, the strength of the nut bolt, the diameter of the nut bolt, there is one specification which we are taking over here for an example, and that is the length of the nut bolt. Now, the customer comes over here and says that I want the length of the nut bolt to be 6 inches long, plus or minus 0.3 inches. Now, in this situation, your lowest specification limit becomes 5.7 inches, which is 6 minus 0.3. And since he said plus or minus, so the upper specification limit becomes 6.3, which is 6 plus 0.3, right? Anything which you produce between these limits, that's 5.7 to 6.3, is good for the customer. Customer is going to accept it. However, anything which goes beyond that is a defect. Fair enough, there's a defect, so what? Defect would it would make you to do rework in the process. Now, rework itself is additional cost because you have to allocate your resources again. The raw material which got wasted, what about that? It's just additional cost, right? And it's of no use. The manufacturer has to take that cost because he made a product which was defective and nobody is ready to buy a defective piece. There is just no use of a defective material, right? So that's what the aim of Six Sigma is. Six Sigma aims at reducing the variation to a level that entire variation of the process fits within the limits of the customer. At the moment, you might not have complete understanding of what is Sigma and what is standard deviation, but then at a very high level, let's understand what Sigma is. Sigma only talks about how many standard deviations can be fit within the upper specification and lower specification. If you can fit overall 12 standard deviations, that's 6 towards the upper side and 6 towards the lower side of the mean, then your process is capable of producing only 3.4 defects per million, right? And what is standard deviation? Standard deviation is nothing but the average distance of each data item from the mean. Right? I re-emphasize that once again. Average distance of each data set from the mean is your standard deviation. How much is your data deviating from the mean, from the target value, from the average, right? So that is standard deviation. What is Six Sigma? It's a methodology, breakthrough methodology, which was developed by Bill Smith. Bill Smith was, at that point of time, he was working in Motorola, and he's credited as the father of Six Sigma. Now, one day, the story goes like this. One day, Bill Smith, along with his friend, was sitting in cafeteria of Motorola, and they were having a discussion to make processes more predictable, to take SPC, statistical process control, to next level and come up with much more predictable approach, come up with a process improvement approach. So that's how they started off with the journey of Six Sigma. It took a lot of years for Motorola to come up with the Six Sigma as official methodology. Now let me ask you a question here. So Six Sigma was brought into the industry by Motorola. Motorola was a pioneer in introducing Six Sigma. They did pretty well. They saved a lot of cost with Six Sigma. But where is Motorola today? Motorola got sold out to Google. Google really didn't find value in it, and they wanted to focus only on their software business. They sold it out eventually to Lenovo. Our company got sold out 2 times, right? Where is it? What happened? Is it the failure of Six Sigma? Not really. It's not a failure of Six Sigma. It's a strategy failure. So they kept on focusing on the same product, and eventually the customers were not interested in that product, right? The customers were trending towards buying more smartphones. Even though the product which Motorola was coming up with was of very high quality, the cost of production was lower, they were having lesser number of defects. Does the customer really want that product or not? That's a question which has to be asked. Right, so it's not a failure of Six Sigma. Six Sigma will not deliver the results to the company alone. You require other methodologies as well. For example, blue ocean versus red ocean strategy. There are different other things in the market, and it's a combination of everything that has to be brought in. What is the fundamental definition of Six Sigma? The fundamental definition is the center of the process is away from the nearest specification by 6 standard deviations, right? If you have to bring it away by 6 standard deviations, there are 2 ways how you can do it. One, take away the upper specification or the lower specification, ensure that they are broad enough to have for you to be able to fit 6 standard deviations within those limits. Is it really possible? You really cannot influence the customer's specifications. It's a specification given by the customer. Customer is not going to change it. You can negotiate if you want, but I don't think it's going to be possible for the customer to relax the limits that they have set. Now, if they are not ready to budge the boundaries that they have set, what is the other alternate? Reduce the standard deviation so that you can now fit 6 standard deviations within those limits, correct? So that's what Six Sigma focuses on. It focuses a lot on reducing the variation. Origin of Six Sigma, this was coined by Bill Smith, who was an engineer in Motorola, as we discussed. It was started in late 1970s, where Motorola started experimenting with problem solving using statistical analysis, and it took around 17 years for Motorola to officially launch. Not completely 17 years, because it was Motorola started experimenting with this in late 1970s, not early 1970s. So yeah, but it took a lot of years for Motorola to officially launch this program. Then it started growing in somewhere around early 2000, in late 1900, 1996, 97. Jack Welch, who was the then CEO of Six Sigma, then CEO of GE, he launched Six Sigma in GE. Now he made it a mandate for the management positions, for anybody to be eligible for management positions, they need to have a Six Sigma certification, right? So 1998-99 Green Belt exam certification became the criteria for management promotions, and then 2003 Green Belt became the criteria for promotion to management roles, right? So this is how GE promoted it. Why is Six Sigma required? Earlier the business model was, since the competition was limited in the market, you can afford to look at your cost price, which is the combination of your cost of good product, plus there is of course a cost of rework, cost of inventory wastages because of the defective products, plus you add profit on that, and that becomes your sale price. Today, can you really govern that? There's so much of competition in the market. The price is already given out. Price is there in the market, and you need to be competitive enough. Today the model is price minus the cost, which becomes your profit. Now if your cost is equal to the price, you have zero profit. Worse, if your cost is above the price, how long are you going to stay? The only way to deliver more profits is to reduce the cost, and that is where Lean and Six Sigma comes into picture. Cost of poor quality, let's look at the sum of the cost of poor quality here. There are two types of costs, cost of quality and cost of poor quality. What's the difference? Cost of poor quality is where you have to rework. The work that you have done has gone waste and the raw material has got wasted. That has to be reworked. You have to do the work again. Wastages, rejects, rework. Customer has returned the material to you and you have to either destroy it or you have to rectify it. All that becomes your cost of poor quality. Cost of quality is the cost which you incur to ensure that you deliver good quality. Six Sigma organizations, different organizations that have worked on or that have implemented Six Sigma. GE, Jack Welch, initially who was the CEO of 3M, he had all 300,000 employees. He made it a mandate that all 300,000 employees must be Six Sigma certified. Then he moved on to 3M and pretty much implemented the same structure, same methodology in 3M as well. New CEO, who was Jack Welch from GE, he requires all 3M employees to become Six Sigma certified. We have Six Sigma in DuPont, CSC, LG, Sun Microsystem, Elite Signals, EXL, IBM, Motorola, Boeing. Talk about the company, and today we have Six Sigma in those companies in various different organizations as well. It is rapidly increasing in healthcare, financial, military. It's increasing everywhere now. Earlier the myth used to be Six Sigma can only be applied into manufacturing. That's a myth. I have done consulting work and I know that Six Sigma can be applied or is applied in services, design, purchase, production, IT, M&S, HRM, quality, administration, management. Talk about any industry and you can apply Six Sigma concepts in that. Let's look at what you can lose by not implementing Six Sigma. If your process is, if you get to baseline your process and your process comes out at 3 Sigma, which doesn't sound too bad considering Six Sigma is industry standard. But look at this. Because of the bad word of mouth or because of your not so great quality, you can have 66,807 defects per million opportunity. And with that, what would happen? The word spreads faster, right? You are in threat of having 25 to 40% of your sales go away to your competitors because of your quality issues. And look at Six Sigma. If your process is Six Sigma compliant, you will only be losing less than 1% of your sales. That's the difference. That's very high. What does Six Sigma tell us? Six Sigma tells us, Six Sigma first of all can be implemented only into processes what we measure, right? If you don't measure, Six Sigma is a statistical approach. How can we apply statistics unless we know what is our performance and if we have not measured it? And they say that you would measure something which you would value. If you don't value it, you would not measure it. Right? Typical results that we've got, companies that properly implement Six Sigma, they have seen profit margins grow 20% year after year for each Sigma shift. That is huge. Since most companies start at about 3 Sigma, I've seen companies that's starting below 3 Sigma as well. But most companies start at 3 Sigma. Virtually each employee trained in Six Sigma will return an average of $230,000 per project to the bottom line, right? Until the company reaches 4.7 Sigma, right? So that's again is huge. That becomes a big business case for companies to implement Six Sigma. Six Sigma results, companies like GE, they achieved on an annual basis, they have achieved $2+ billion saving. JP Morgan is 1.5 billion, Motorola 16 billion since inception, Johnson Johnson 500 billion. Huge savings. Variation. Let's look at what is variation. So Six Sigma aims at controlling the variation. That's what we have spoken about some time back. It aims at getting the variation to reduce, or it talks about reducing the standard deviation. If we reduce the standard deviation, that indirectly we are saying that we have reduced the variation in the process. So higher Sigma, mind it over here, it's higher Sigma, not higher standard deviation. Higher Sigma is higher the sigma level that we have, lower is the standard deviation that we have, because you are able to fit high number of sigmas within the specification limit without moving the specification limit apart, without getting them move further apart. And with this, we will be having better performance, fewer defects. So in this example, what you see on the screen is the yellow zone is beyond the lower specification and the upper specification limits, and this is an area marked in yellow as defects. And do you want defects? You really don't want. Reducing the variation, what has happened, bring the process within the 6 sigma level, and everything is fitting into the lower specification, upper specification limit. You have 0 defects, which is and not anything that you're not producing anything which is not meeting the customer specification. That's a great thing. That's something which you really want. Six Sigma methodology, what we would be learning in our session is DMAC approach. It's an innovation algorithm. So here we already have an existing process and we want to improve that process. So in that we will implement the DMAC approach. DMAC approach, as we said, is define, measure, analyze, improve, and then eventually control. There's another one, design for Six Sigma. This is where you're implementing a new process and you're building a new process with Six Sigma in mind. So that is DMA/DV, define, measure, analyze, design, and verify. Different phases that you have. As we said earlier, in define phase, we talk about what are the customer's expectations, what the customer really wants, and what are we going to improve. Look at the different customer expectations, take one problem area, that becomes your define. Measure, what is the frequency of the defects, how much defects we really have, baseline your process. Analyze, when, why, and where do defects occur. Find out the root cause. Improve, how can we fix the process? How can we fix the root causes to improve our problem that we aim at improving? Control, how can we make the process stay fixed? How to ensure that we don't go back to old ways of doing the process and having the similar kind of defects as we had in the past. How to stay fixed. The approach that we have is convert the practical problem into statistical problem, convert the statistical problem into statistical solution, and eventually convert the statistical solution into the practical solution. Six Sigma initiative, it integrates all these efforts, which is SPC. SPC is statistical process control, knowledge management, design of experiments, re-engineering, benchmarking. ISO 9000 is nothing but the quality management system, problem solving teams, and strategic planning. The path for Six Sigma, we are starting over here with yellow belt. So you are taking the first step towards Six Sigma. The yellow belts are generally the people who are working inside the team to bring in the improvement. Then we have the green belt moving up. From green belts are generally the project leads of small projects. Then black belt, they undertake complex cross-functional projects. Master black belt, they mentor all the belts, and they identify the real pain areas. They identify which project has to be prioritized. They pretty much work for a strategic level, and they train people on Six Sigma concepts as well. Six Sigma challenges and misconception. The biggest misconception which I can point out over here is it is only for manufacturing. It is absolutely not for manufacturing. Ask me, I have done Six Sigma consulting work for IT, ITES, manufacturing, healthcare. Talk about any company, any industry, and it can be implemented over there. Yes, it started, both Six Sigma and Lean, they started with manufacturing. It is easier to implement in manufacturing. Doesn't mean that you can only implement in manufacturing. So that becomes your biggest challenge and misconception. There are other challenges, other misconceptions which we have, like proper implementation needs a statistical genius. Not at all. You just need to be good and well versed with the tools and techniques. We have good tools and techniques which can be used, and those tools and techniques can give you the similar results. You need not be a statistical genius to be able to read those results which we get in the tools and techniques like Minitab, and bring on improvements. Of course, you still need to have out-of-box thinking, right, to come up with the improvements in the process. Here is a look at some misconceptions about Six Sigma and some challenges to Six Sigma deployment. So stakeholder support. Without the stakeholder support, you cannot succeed in Six Sigma. Why? Because it is always a top-down initiative. I have seen quality working when the management commitment is there. Without the management commitment, people tend to deviate from the quality work, right? And that is why we always say that Six Sigma initiatives are top-down initiatives. It needs to be driven by the top leadership. Employees in a company can talk about Six Sigma deployment only when the top leadership supports it. Without the top leadership, it just won't be successful. Measurement system has to be crisp. Six Sigma deployments are fed on regular doses of data. Now, everything is based on data. What will happen if your data is incorrect? Your process baseline will be incorrect, the judgments that you will be taking is going to be incorrect, and eventual results are going to be incorrect, right? Incapable measurement system would lead to bad data, and bad data would lead to bad decisions. Analysis paralysis. Analyzing a piece of data is good, but spending hours and hours and using variety of tools to extract some piece of information will lead to analysis paralysis syndrome. Have a time-boxed approach, stay focused, ensure that you complete your analysis within a specified time period. Communication. Agreed, Six Sigma is a top-down approach, but it will be process resources who will decide the fate of the deployment, right? Resistance from the level 1 and level 2 employees arise only when the purpose of Six Sigma deployment is not well communicated. What is the purpose? Why are we doing this? How is it going to benefit the level 1 and level 2 employees is very important for us to communicate it to them. In summary, Six Sigma is amalgamation of lean, that is waste elimination, and Six Sigma, which is variation reduction. Six Sigma approaches are deployed through projects supported by top leadership. Enough investment needs to be made on the model before companies adopt Six Sigma deployment approaches. Six Sigma is not for weak-hearted, because of course you would be having a lot of discussions on the table, a lot of resistance. Any change which you might have seen this, any change that you try to bring into the system, people are going to resist that. And with Six Sigma, be assured you're going to bring a lot of changes. So it's not for weak-hearted for sure. Successful Six Sigma implementation needs good measurement system. Six Sigma can be applied to most disciplines, as we discussed some time ago, with an industry and most businesses units within an organization. Financial results are the only perfect measure of how project success is measured. Always talk in terms of dollars. Stakeholder support, measurement system, excessive analysis, and poor communication are challenges to successful Six Sigma implementation and needs to be taken care of. Right, so the roadmap that we have, we will talk about the define phase, measure, analyze, improve, and control. In the next module, we will talk about the define phase in detail, and that's where we'll get started with the define phase. So that's all about the first chapter, that's introduction of Lean Six Sigma. The first module here we completed, and the next module is that we're going to start is for define phase. Thank you very much for listening to the first module, and let's move on to the second module.